So thanks for waiting. This is Alessio Bondi. I'm AM sales representative of CRP Technology. It's an Italian company, and we do materials and parts, 3D printed parts with our Windform materials that I'm going to talk about today. Basically, the company is a group of companies. We have CRP Mechanica, which takes care about all the CNC machining and metal works, and CRP Technology, where we have SLS machines to print parts with our materials, and also where we have our development and sales of Windform material, as well as a sister company in the United States is CRP USA. Here we have just a headquarters of CRP USA, CRP Technology, and CRP Mechanica. Basically, Technology and Mechanica, we are in Modena, next to each other, the Motor Valley, the Italian Motor Valley, and CRP USA is in Mooresville, which of course is the American Motor Valley, let's say. Where we work, it's a mix of different industries, of course, aerospace, that's today is going to talk about, then also avio or drones, motorsport, and automotive and sports application. Here, as I said, we're going to talk about our composite materials. Basically, we have different kind of system for printing. In Italy, we have 10 sinterstation. We just print in SLS technology. In the United States, we have 6 sinterstation. Basically, it's a mix of what we call the large frame. So it's 550 by 550 by 450 height, till the small frame, which is 280 millimeters, of course, by 140 by 180 millimeters height of the machine. So between this and that, we have 400 by 400 by 450, and 6 small medium 350 by 320 by 400 of height. In the United States, they apply more or less the same capacity, the same size of our machines. What are the benefit? What we can do with our 3D printing materials? So it's first of all, it's a total freedom. I mean, you know, when you design a part and you want to print the part in 3D with SLS technology, you basically have almost no limits. You can produce parts with the complexity, with a high complexity, and very difficult to realize with the traditional production system. We have a high level of customization. Typically, we have customers, they do a small lot of one item and then little changes to similar item, they do another lot. So every part can be really customized and printed to suit the specific application of our customer. Then we have reduction in product and project realization timing. Means that in a short term, let's say typically in 24 to 48 hours, you go from a drawing to a part on your desk. So part of our success is a high-speed response to the customer in terms of quote and also in terms of production, thanks to our capabilities. What we can do, it's functional, space-ready parts and flight-ready parts or structures or equipment application that we see later, what really we can do. Lightweight, weight, you know, it's important, and it's a goal to reduce it, so we can really reduce the weight of the parts we print, and we have some cases of material replacement where it was a very winning situation. We have a polymer material, so all that are polymer materials, but we developed with high temperature resistant, and you can use for mock-up, for assembling, fitting functionality, and also to make tests before you launch. That's an overview you can always find all the information on our website, www.windform.com, where you can download mainly all the technical specifications and certification and all the related technical information. We have basically 10 materials, 3 of them carbon fiber reinforced, so all are polyamide based, carbon fiber reinforced. 2 of them are glass fiber reinforced. 1 is aluminum fiber. 1 is pure polyamide. 1 is an elastomer, and 2 very interesting material recently developed are flame retardant. The main features why people choose this kind of product is by strength and lightness, so very low, it's low density but good strength. Space ready, especially our Windform XT, it's already widely used for space application. We can do CNC machining thanks to our sister company CRP Meccanica. It's waterproof. We have products which are already skin contact approved, of course, for other type of application. And we have as well a material we can print with very nice and very good electrical insulation and very good flammability response. Some examples of our top line. The space one is XT 2.0. You can see the density, it's just a little bit above 1, so 1097 grams per cubic centimeter. We have a good HDT, it's 173, a little bit above 173 degrees, and a UTS of 83,84 megapascal. This is widely used for space application. Then we have is a bigger brother, Windform SP, which is a little bit more heavy. Density is 1.106, but you see HDT is higher, is 186. UTS is a bit lower, is 76 megapascal, but there's a very good elongation at break at 11.38%. Then we have a Windform GT that's used for example, for drones application. We have many customers which are doing drones. You can see the characteristic, the features of a little bit lower HDT compared to the other 2. UTS as well is 56, but the main features is elongation at break, which is 1482, and very good manual and very good surface finishing is 145. As part of the family is the electrical insulated material, is Windform LX 3.0, which has a CTI of 600 and very good HDT as well, 175, and acceptable UTS 60 megapascal, and also good manual and good surface finishing. So the first 2 are, as you can see, carbon fiber reinforced, and the second 2 are glass fiber reinforced. Here we have the newest Windform flame retardant, FR1 and FR2. FR1 is rated according to UL 94, it's a V0 rating, and HP as well, and this passed also the smoke density test. As well as features of the material, we have a good density, it's 121 grams per cubic centimeter. A good HDT, so 162 degrees, a melting point of 181. And here you can see the tensile strength and tensile modulus of 65 and 6,981 megapascal. The hardness sure is 82. The second of the family of flame retardant is Windform FR2, which is the only white material we have. All of our material are black. And this is UL 94 HP rated and also passed the smoke density test. The flame retardant material, the FR1, is a carbon fiber. The FR2 is as well glass fiber reinforced. Last born of the family, it's Windform RS. That's a very strong one. It's with a density of 121. You can see a very, very good HDT for a polyamide, for a polymer. Okay, it's a carbon fiber reinforced. It's 191 degrees Celsius and 197 as a melting point. Look at the tensile strength is 85 megapascal and the tensile modulus is 6,638 megapascal. And with an elongation neck break, so it's not bad. It's 9.46%. This one is very good for heavy duty applications. These are the main reason why the customer and the companies are considering Windform materials. You can say it's a best UTS density in the market. It's passed out is a very important outgassing test, and also CTI, very high CTI, and flame retardant. So these are multiple compliance of our materials. Very high resistance to temperature and low density. Some of them also excellent mechanical and electrical capabilities, and is the only material which is carbon fiber reinforced and also flame retardant. So Windform materials are really advanced for different kind of application where also specific compliance are required. Few case studies. Here we can see a few case studies from UAV, avio, and aerospace applications. We start from this first 3D printed pocket cube deployer. So we have the challenge. The challenge is to develop an updated version of a space qualified 6B pocket cube deployer, AlbaPod V2, plus moving ejection mechanism and door assembly. The solution was a laser sintering technology used using Windform XT 2.0. What the customer get is a functional 3D printed pocket cube with a redesigned shell and also improved, especially in terms of weight, manufacturability. Consider that really in a less than a week, you get the parts. So it's really easy to access technology, and is also incorporating a number of safety features. Space mission was in the beginning of December 2019. It was the pre-pandemic time. 6 pocket cube satellites were launched in orbit via 3D printed AlbaPod V2 mission Alba Cluster 2. And Alba Cluster 2 has been in orbit for 100 days. A new launch is expected soon. In this case, we can see again a 3D printed 1P pocket cube, where the challenge was also to build the first time an entire pocket cube flight ready space using additive manufacturing carbon fiber composite. So this one was the real first one. As well, we got all the drawings we developed together with the customer, the parts, and then we manufacture, thanks to a laser sintering technology and thanks to Windform 2.0, this beautiful pocket cube you can see here. It's fully functional, 3D printed, and is space qualified with some electronics, camera, radio system. So it's full equipped. Again, is another case of 3U CubeSat form factor. As well here, the challenge a demonstrator that can be in a low Earth orbit. As well, solution was the laser sintering, and the result is a 3D printed CubeSat structure. It's with these are very important advantages we have seen before as well: mass reduction, component integration, outgassing control, thermal expansion, and low surface roughness. All our material have a very high surface finishing that permit to have this obviously low surface roughness. This 3D part has passed the control and testing criteria and is fully complying with the LISA standards, Université de Paris. We have developed with them this kind of CubeSat. Here, a little bit different. We developed with the Italian company Leonardo, which is involved in different sectors as defense and avio. A 3D printed wind tunnel model. So we developed all the parts and the nose of the cockpit, all of them as well in XT 2.0, propellers. So the challenge was to manufacture a scaled mock-up model to be tested to test aero design solutions. In this case, also the way it's very easy to modify the printed parts. So in case the engineer should modify some parts, we can really reprint one and in few days send back to them. The solution as well, the laser sintering technology, and the result was a complete mock-up ready for wind tunnel with a tilt rotor capable to simulate different configuration in flight mode. Here, as I said before, we have an example of a drone. Is a drone manufacturer, Hexadrone, that has developed is a Tundra 3D printed drone. It's quite big. It's a big toy. And the design and manufacturing was easy thanks to our same solution. So it's 3D printed using XT 2.0. The challenge was to make a product to work in extreme weather conditions. So they came to us to ask specifically for a drone which was able to fly with the extreme weather condition and waterproof design. So we printed all the parts that the customer has developed. The forearms supporting the body frame, where the arms were printed in 3D, thanks to the XT 2.0, which is the most popular, as you have seen, and the rest of the components in SP, which is a bit more flexible, but still is a strength material. The result, as you can see in the picture, was a ready-to-use drone to test the assembly capability, perform flight and landing tests in real life in extreme weather conditions. So it works in a hard environment. So this one was the last one. Alessio, and here are our contacts in case you are interested to know more about Windform materials and our capabilities. Thank you very much, everyone.